Why can't aluminum electrolytic capacitors withstand reverse voltage? This is the commonly used aluminum electrolytic capacitor. It is well known that aluminum electrolytic capacitors are polarized, with the longer pin being the positive electrode and the shorter pin being the negative electrode. In circuit design, the voltage of the positive electrode of the aluminum electrolytic capacitor must be greater than that of the negative electrode, and it must not be connected in reverse. To understand why aluminum electrolytic capacitors cannot withstand reverse voltage, let's first look at a manufacturing process of aluminum electrolytic capacitors. The anode of an aluminum electrolytic capacitor is formed by placing a piece of aluminum foil into an acidic solution and then electroplating a very thin and dense layer of aluminum oxide on the aluminum foil. This aluminum oxide is the dielectric of the aluminum electrolytic capacitor. Then, an electrolytic paper containing an electrolyte is added. The electrolyte contains conductive ions, and it is the true cathode. Next, the cathode aluminum foil is added and rolled together with the anode aluminum foil and electrolytic paper, and lead terminals are added. Finally, after being enclosed in an aluminum shell, the commonly used aluminum electrolytic capacitor is formed. When a forward voltage is applied to both ends of the aluminum electrolytic capacitor, negative ions gathered near the aluminum oxide dielectric, and positive ions gathered near the cathode aluminum foil. Aluminum oxide has relatively good insulation properties, and the aluminum electrolytic capacitor exhibits the characteristics of a capacitor. When a reverse voltage is applied to both ends of the electrolytic capacitor, negative ions gather near the cathode aluminum foil and positive ions gather near the aluminum oxide dielectric. Many hydrogen ions are present in the positive ions. Since the size of hydrogen ions is relatively small, they can penetrate the aluminum oxide dielectric and reach the anode aluminum foil. At this time, hydrogen ions will be converted into hydrogen gas, and the expansion force of the hydrogen gas will cause the aluminum oxide dielectric to fall off. At this time, the aluminum electrolytic capacitor fails. Therefore, after reverse connection, aluminum electrolytic capacitors usually appear bloating, heating, or even exploding phenomena. Generally, aluminum electrolytic capacitors will quickly fail when the reverse voltage is connected for 1 to 2 volts.